Hi guys, good afternoon, and sorry for the delay. My laptop is actually yeah. So today I'll be presenting on image forensics analysis. That is basically I'll be covering for PNG only, not any other format, just for PNG. Yeah. So a little bit of introduction. Who am I? So I am Parmar. And currently I am working with Palladian Networks as a security engineer. Partially I do security researches and also play CTS. But I'm not a full-time or I'm not a full-time researcher also, because I have got a job to do. That's okay. Yeah. So today's agenda will be introduction to PNG, underlying structure of PNG, played CTF that I played last year, in which I came to face this PNG, and I had pretty much time in solving this question, but at last also I was not able to solve it. Yeah, but I got a good understanding how it works. So what is a PNG? It's a portable network graphics. It's a raster graphic file format that supports useless data compression. Actually, it was built to replace GIFs that was transmitted along internet. So it's not a, you can say, good graphic quality which can be printed, but yeah, you can transfer it over internet. Yeah. Is it visible?
Yes.
Visible to everyone? How?
Please a little more.
Yeah, how I can zoom?
Command C plus. Command C plus.
Option C. That's it.
So this is a header of PNG, right? Means if we say every file has a header, without header we cannot identify which is the file format of this particular file, right? So this is the format of header. So this particular value 89 here has a high bit set to detect transmission system that does not support 8-bit data to reduce chance that a text file is mistakenly interpreted as a PNG or vice versa. So it's a 8-bit, you can say, header, right? Now what happens is sometimes we have only 7-bit header signature which is detected. So at that time the PNG is mistakenly interpreted as a text file. It is not taken as a PNG. So this creates a problem when we are transferring to internet. So it's not taken as a PNG. After that 54E and 47 is just a PNG name. So it's a value for PNG. Now this is important. 0D and 0. What is this? This is a DOS style line ending. In, you can say, when we were using typewriters, right? In typewriters, what we used to do, we used to type the line, then we used to roll, and then take the cursor to the first line, to the first character of the line, new line, right? This is the same kind of thing which Windows does or DOS does, right? 0D is for CR. CR means getting the cursor to the first line without rolling the paper. I am just using a layman so that we can all understand. Yeah. And 0A is a turning of the page, that creating a new line, going to the new line and start writing from that left side of the page. Yeah. 1A. byte stops display of the file under DOS when command type has been used, the end of the file character. So it's just a simple end of the file character which indicates the reader or interpreter that the file has been ended. Now the last one is Unix style line ending. Now in Linux and DOS we have a little bit of difference that Unix does not use that CI. Means it does not use, it continuously prints the line. It does not go to the next line and to the left. It continuously prints the characters. This might be visible. Is it visible?
Yes.
Yeah.
Absolutely.
Yeah. So a PNG is divided into certain chunks. That you can say certain blocks that we create. Right. Every data is created and stored in blocks. So PNG has four type of not 4, 5 type of chunks, but we'll look at it. But now the length of the chunk, what is a chunk actually? What is a chunk made up of? So it's a length, right? The first 4 byte indicates the length of the chunk, how many bytes it is having in the chunk. Then it is chunk type, which type of chunk it is. There are different type of chunks that we'll see. Then it is chunk data. Chunk data means length bytes, means what is the exact payload you can say in that chunk. What is the exact value is that chunk is storing. Then it is CRC. CRC is basically to check whether the file is damaged or not. As we all know that CRC we used to learn in engineering, that if the file has been transferred or if the file has been damaged, to check the integrity of the file, we use CRC. That if the file has been damaged or changed or not. Right? Yeah. So these are critical chunks, basically, that a decoder must be able to read these chunks. Why? Because without these chunks, a decoder cannot understand what the file format is or what the particular file is showing or what is the data in the file, PNG file. So these all critical chunks should be read by the decoder. So first one is IHDR. IHDR chunk, it contains the image width, height, depth, color type, compression method, filter method, and interlace method. So it's a kind of header. Means you can say the first header chunk after the header of PNG. It's a first chunk that will be read by the decoder to identify the exact, you can say, metadata information of the PNG, that what it is, how the color coding is, all that. Then it is plate. Plate contains the list of colors, that the color coding of the colors, what are the colors that are used and how much quantity it has been used, right? Then it's IDate. Now, IDate is very important chunk. The PNG that contains the actual data. This all you can say are metadata, that what the PNG has. But actual data, actual image is stored in IDate, which is, you can say, if you do any changes in IDate, then you will not be able to see the image at all. That's what the challenge right now is. That's it. And IN is a end of the mark, means end of the file.
These are different types of chunks.
Yeah, these all are different types of chunks. So these all are like a blocks in PNG. The first it will be header, then it will be IDate, then it will be IN. So IN can be multiple. IHDR and IN will be the same, means same, only one. But IDate can be different. Multiple IDate chunks there could be there, depending on the size of the file or on the size of quantity or quality of the image. Yeah. So this was the challenge, that we had in Plate CTF 2015 when we used to studies. So we used to play CTFs at that time. So in this, actually when I first saw this question, I was under impression that it will be a simple forensics. Like I used to do forensics, image forensics, like if an image is changed, or you can say brightness is increased, color coding has been changed, so that we can identify from a site called photo forensics. Even you can have a metadata that from which device it was taken. So I was under impression that okay, this will be a simple thing and nothing will be there. But I was wrong, to be frank. So when I downloaded the image, it was opening like this, a corrupted image file, which shows nothing. But the flag was inside that. Yeah. So after that, I tried to find out the header. That if I can have some information from the header itself, that if there are some changes, because most of the time when I was doing forensics, in the, you can say 70 or 80% cases, I was finding that the header has been changed or misplaced, so that we cannot open the file again. So I started from the basics, that let's find out the header first. If it is correct, then we'll move forward. So in there, I found that it is not correct, because it's a normal PNG header which contains 0D0A. Now 0D0A is here. You can see. Right? It's a DOS file name which we discussed. Why it is important? That decoder has to move to the left in the new line to understand the characters, to understand the image. Now here it's not. So it will just simply, decoder will move towards the right. It won't come to the new line and it will not decode that particular value. So we will not get that particular value, or we will not get that PNG structure, right? Yeah. After repairing header, there was no success. I was getting the same image. So I found out that okay, the image is not helping, or the header is not helping. So I'll have to do some more research how I can repair, because there was a question, so I was pretty sure that there will be an answer. So I found out that I'll have to do something more. Yeah. It's visible, right? Then I use this tool called PNG check. Now what this PNG check tool does is it will display the information of chunks that are present in the PNG. Actually I tried to repair this PNG with different tools also, but it was not helpful. So at last I came to a conclusion that I'll have to do it manually only, that I'll have to check one by one which are the headers, what is the problem, where is the problem, and then I'll have to find it out a solution. So I use this tool, PNG check, and in that one I found that a header, that is HDR, is also good. Here you can see invalid chunk name HDR. Everybody can see? Right? Yeah. So again, my mind got stuck that okay, invalid chunk name HDR. How it is possible? A chunk name should be decoded in a proper way, right? Then I came to know that okay, let's analyze the hex again, and we'll see if there is any problem. Then I repaired this HDR. I'll tell you how. This invalid chunk name, actually what happens, that decoder rates one by, right? If there is H, then D, then R, then it will display HDR. So it is missing I, it should be there. So the value of I was missing in that hex, particular hex. So what I had to do is, I had to just input a value which will take for I, the particular value for I, so that it will count all the four values and it will give me IHDR instead of HDR. I hope everybody's coming with me, right? If there are any questions, you can ask me. Yeah. So I repaired that from HDR. I repaired to IHDR. So it opened a little bit of image. This one. Just a little bit of image, it opened. Yeah. So I was more excited that okay, a little bit of image is opening. So I'll have to do something more that full image will open. Yeah. Then we had, as I mentioned, that first is IHDR, then we have IDET chunks, and then here IN chunk, right? Now IHDR and IN are one only. The multiple IDET chunks could be there. So what I had to do is, I had to now go for IDET chunks. That now the problem is with image only, image data only. So I'll have to check each and every IDET chunks in order to recover the image. So I started. Yeah. So after solving that error, that HDR, right? Now this PNG check, what it does is, it checks the chunks, all the chunks one by one, right? So it first encountered the error in HDR chunk. Now I repaired it. So now it will move down to det chunk, and the first det chunk that will have error, it will encounter that. So I came to that IDET chunk. Here you can see a CRC error in chunk IDET, right? You can see. What was that? Actual, sorry. Yeah, actual is F027404 and it should be 5A745D00. So there is a problem in CRC. So I came to know that there is a problem in the det chunks, that is, just a second. Here. So now here, in CRC I was getting it, right? Now this length in chunk type, it was okay. That I checked, that if it is giving the same value or not, right? So that was fine. Now only variable was this chunk data. In chunk data, there is something that is not matching, and that's why I am getting an error of CRC, that it's not a perfect or it's not a valid PNG that should be there. And if it is a valid PNG, then it should match CRC. Okay. Now here you can see the chunk DAT, then there is some sign, right? And I got the offset, which was the 207D. Now, I was having a way where to start. That I got the offset, that was creating a problem, right? And pretty much I figured out that also, what it is creating a problem. Because earlier in HDR, we had same thing, that it was not reading full length. HDR, right? IHDR. So here also we are getting same error, same type of error, you can say, that it is reading only D8, not I. It should be IDET, but it is only reading D8. So I had to repair that also in order to get a new error. So I understood from this point that I will be getting a new error, new errors and new errors. It is not an easy task. Yeah, here. So here I found out that 100 entry is added. So you can say it's that's why it is not reading the full name I did. So I had to remove that. Here I removed that one and I displaced, or you can say I replaced the full
See.
IDET chunk name to the same value. That it was starting from 207D, right? It should be here. So from here it should be having IDET should be coming from there. Yeah.
IDET is basically the PNG data that you are talking about.
Yeah, correct.
CRC is a checksum of that data, if I
Yeah,
right?
correct.
So what does that, the CRC being wrong, have got to do with the name of the chunk itself? So you are basically just repairing the name of the chunk, which should be
Yeah.
IDAT, and what it was DAT.
Yeah.
You wanted to replace it with IDAT.
Yeah.
But what has that got to do with the checksum that we are calculating? Because the checksum is being calculated on the data itself rather than not the name of the chunk.
Yeah, it will come. I'll come to that. Okay. So now another problem that was there, that the chunk name was not repaired. So we repaired that also. Now we will fall into a new problem that this man is saying about. Yeah. Now this is the main problem which happened. Can you see? The file is corrupted. It seems to have suffered DOS to Unix conversion. Now what this error means? Yeah, correct. I'll get you to that slide again. Yeah. Here you can see a DOS style line in, right? It is using CRL. So you can say the value should be 0D 0A over here, right? The DOS style should be there in order to read the file. But here what happened, that we got only 0A, that is a Unix style file in, right? So this was the problem. So when the PNG was transferred from one place to another, it was, you can say, interpreted as a text file. So it was not interpreted as a PNG file. So this caused an error that PNG was not opening at all. Here you can see, when an image is downloaded as a text through FTP ASCII mode, with each 0D0A bytes are tupled and is truncated to 0A, right? So now we got an insight that okay, there is some problem with this two bytes, that is 0D and 0A, where the value should be 0D0A, the value is only 0A, which is not opening the file and which is causing the CRC error, right? Yeah. So now we knew that there is some problem with 0D and 0A. So we started analyzing all 0A values. All the 0A values that are present in the PNG. So we started analyzing from the top of the PNG to the end of the file. So there were around 10 IDET chunks. In 10 IDET chunks, there were around 200 to 300 0As. So it was, this all I was doing manually only. There is a script available for this also. Professionals have developed one script to solve this issue. That is brute forcing actually. Every 0A value, it is brute forcing and checking the CRC. That let's say for example, I have one 0A value, right? I am replacing it with 0D 0A. Then it will check for the CRC. If the CRC is matching, then it will keep the value. If the CRC is not matching, then it will move forward and discard it. So that's the basic concept of the script. Yeah. So only one particular value we need to change in order to make the CRC at every chunk of every chunk, right? Yeah. So this was the half of the image that I was able to open by checking every 0A values and replacing it with 0D 0A. And then I was just saving the image. Then I was checking if the image is opening or not. If it is not opening, then I'll move forward. I'll open that PNG again, move to another 0A, then I'll replace 0D 0A, then I'll save that image, and then I'll try to open again. So this was the half of the image that I was able to open. Yeah, but one thing I got sure that this is the base logic that we need to follow. Yeah, I'm not a professional and I'm not a coder also, so I didn't know how to code for this one. So yeah, but I was there that this should be the logic. Yeah, this was the full image. And here we are having the flag. So there is a Python script available in GitHub also, that if we find write-ups for this late GTF 2015, there is a complete set of PNGs, corrupted PNGs, uncorrupted PNGs, and the fixed PNG.py. Python script also is available. Yeah, the open source tools I used was PNG check, PNG utils, and mostly Hex editor. Hex editor is a base for forensics. If you want to do any forensics, any digital forensics, you should be not pro, but you should have basic understanding of Hex editor. Thanks. So, any questions? Yeah.
Tell me this: how did you conclude that it's a problem with the data part itself? Because you were trying to match the content of IDAT with the CRC that was already present in the header, right? In the chunk, there is data, the
Yeah.
PNG data itself, and then there is the CRC.
Yeah.
So you assume that the CRC that is there is correct, but the data itself is somewhere
No.
missing, because of which there is a
No,
mismatch.
I was getting error in CRC.
How were you? What do you mean by saying that you were getting an error in CRC?
Yeah, I'll show you that. How did I come to know? Here. Here, CRC error in chunk ID. Right? So, the CRC error, CRC should be 5A745D00.
Now, how do we know that? The image itself is corrupt already, right?
Yeah.
Which means that any of the chunks and any part of the chunk would be corrupted, including the CRC itself. You understand?
Okay. So, you are saying that CRC, if the CRC is corrupted,
Yeah.
then how we will know?
Exactly. So over here, how are we saying that the CRC is correct? Why are we assuming that the CRC is correct?
Yeah, that also I'll tell you, because in the next image, I have here down that chunk DAT at offset, right? So yeah, your question is correct, that if the CRC is bad, then what we can do? How we can identify that the chunk is bad only or CRC is bad?
Yeah, in this case, the whatever tool you use, that PNG check,
Yeah.
that is somehow, I don't know how is it doing it, or what it is doing to figure out that the CRC is correct,
Yeah.
but there is some problem with the IDAT part.
Yeah.
Which is what I'm not able to understand.
Yeah, that's correct. That your question is correct, that how we will identify that the CRC is bad or the chunk is bad.
Yeah.
Yeah, for that, actually I was not aware about that also at that time, but I was just, you can say, following my instincts. Following my instincts means I was just looking at that, the chunk IDAT is creating something, right? I was not even looking at the CRC error also. I was just focusing on the chunks. That because at that particular time also, I was just looking at the structure of the file. That what is the structure of the file? Because it was whole new to me. So I was not even considering the CRC part also. I was just focusing on the, okay, where is the file and what is the error in the file. After that, if there is any error, then we will encounter. So I was just following that.
So this was specific to this particular CTF you played, but in the real world, I mean, there could be problems
Yeah,
with CRC.
there would be. Questions? Okay. So thanks all of you guys.